please, if you haven't subscribed, please do not press subscribe button and notification bell. Not share our educative videos online. And I want to share this video with your friends, families, relatives, and colleagues at home. Thank you and God bless you. Now today I'm going to consider the topic called simple harmonic motion under the branch of physics called mechanics. Simple harmonic motion is the motion of the body in a to and fro direction. It's a motion in which the restoring force of the body is directly proportional to its displacement. And here is an experiment to demonstrate what simple harmonic motion is all about. I will be using what simple pendulum experiment. And we have been provided with pendulum ball, a pendulum ball, a meter rule, a stopwatch, a meter stand with a clamp, another necessary material. Suspend the pendulum ball from the clamp as shown in the diagram above. Now we have to suspend the pendulum ball. Now the first thing is to detach your thread and tie it to the handle of the pendulum ball here. So which I've already done now. So you have to tie this one to the pendulum ball. Then measure the length of the thread to make sure that this thread will be enough for your experiment. Because we are told that adjust the pendulum such that line AC here, that is the time of suspension from the clamp to the table should be 90%. So I must ensure that this is more than 90%. So before I first measure it, now we measure from the zero end there, and then from the middle of the pendulum ball to the other end. So when you look at this now, this is exactly 100 centimeters. So now I will tie it from the point of 100 centimeters, so as to have excess of 10 centimeters. So here, so I'm tying it from this point now. So here it is that. Can open the clamp so as to be convenient for you. So you can tie up the other end. So make sure it is tightly done and neatly done as well. So that's that about that. So that's that. So this 100 now. So adjust this pendulum ball in such a way that it is 90 centimeters from the point of suspension. So you measure your pendulum ball in such a way that it is 90 centimeters from the point of suspension. So what you do now is to measure from this point of pendulum ball to 90. So we have the middle of the pendulum ball now to 90 now. To 90. So this is my point of 90. So what should I do now about this? So you hold it like this. Hold it. You can even mark it for. So after marking now, you now fold. So I have to go one more time like this. So this is 90 watts. This is 90 watts. Now you have to confirm that now. Is it 90 as expected? So this is 90 as what? As. So this is 90 now. So we are going to now, after doing that, now what is the next thing? Value now. When L, yeah, when L in centimeter, what is the time? T for the what? Complete what? Observation. You can carry out this one twice in order to see whether you are happy with it. So the time what? Here is seconds, although it's 38. Now let's do it again so as to know how to what? To do the rest. So you stop and then you reset. So now let's count again. We displace this after the count of 2. Slight displacement. Now this is the position of rest. Now we take it like this. Now 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is 38 point what? 38.2 seconds at 90 what? Centimeter. So you can put this to decimal place as well. So we have that is the what? The first reading now. So we have to what? Measure, we have done that for the first one now. So this place pendulum bound slightly, we have done that. Measure and record the content complete oscillation for 90 centimeters. We have done that. Evaluate what? T and root L. Evaluate T and root L. T and what? Root L. So T is equal to what? Small letter T over 20. Then root what? Root L. So we have to do that. We have to carry out that. So these are the what things we have to carry out. So the next thing now is to what? Evaluate T and root L. We are going to do that later. Now repeat the procedure for the 4 other values of L. Let's finish this first. The what? The repeat what? The problem what? Repeat the procedure for the 4 other values of L. Repeat the procedure for the other values of what? L, which is 80 centimeters now. 80 centimeters, we have 80 centimeters. How do you go about that? So the same way of measuring it. So let me bring it up so as to see it. So you measure from the middle of the what to 80 centimeter point. To 80 centimeter point. So you can also use like this to confirm your reading. So this is 80 centimeter. I have 80 centimeter here. So you can as well mark it. So you mark it. So this 80 centimeter here. So 80 centimeter. Ensure that your what? You plan this very well. So 80 centimeter. Then you roll. Centimeter. Now you can measure to ensure the what? The reading. So we have 80 centimeter, you can see 80 centimeter. So now the next thing is to what? Displace this as well. So you reset your what? Stopwatch to 0. Then displace this now. After the count of 2. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 36 point what? For 80 centimeter now we have 36.22 seconds. So I'm still going to do the rest later. So now for the, I have to stop and start the stopwatch. Now next one is 70. 70. So the same way, measure from the middle of the what? So for some, measure from the middle of the simple pendulum board. Then it's becoming more shorter. So I have to from the middle, you can see from the middle here. So this is my 70 here. So you can mark it. So now that's 70. So from here now, you fold in again. So you have your 70 here. So let me just open the clamp here so I can put it here because it can't go another what. Okay, open the rod. Clamp here. So and put it now. So that's exactly what. So you must ensure that this thing is what little bit what complete. So now let's measure that whether it's what. So I'm having what 70 now. Measure it from the point of what? So it's 70 exactly. So we have 70 here. So now we have to also displace this as well. Let's do it together now. So after the count of 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is the 3.12. 33.12. So that is that for what? For the 7 centimeter. Now for 60 centimeter, now for 60 centimeter. So measure 60 centimeter as usual. So let's measure our what? So you place your simple pendulum board Place your same pendulum ball at the extreme end of 0 to measure 60 now. I'm measuring 60. We know that we are using this end here. So 60 centimeter. So this 60 centimeter, please dot the place for easy recognition. Dot the place. So that's this. So let's roll it as we did before. So this 60 centimeter. So you can measure towards to confirm whether your measurement is right. So from this end now to this end, we have about 60 centimeter. From this point of suspension, we have 60 centimeter. So we are good to go. Now for 60 centimeter now, for 60 centimeter after the count of 2. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 at the point of 30, 31 points, 31.20. So 31.20. So that's that about that. So that is 60 for you. So for 50 now, for 50, let's measure our what? Length. For 50 centimeter, let's measure our length for 50 centimeter. Let's measure our length for 50 centimeter. Let's measure our length for 50 centimeter. So you can see the thing is becoming what? So nevertheless, you should be able to measure it as well. So this is 50 centimeter now. From the middle, you have 50 centimeter here, 50 centimeter here. Don't forget, from the middle of the pendulum ball, 50 centimeter is here. So mark the point, then roll it out. So we're going to 50 now. So don't forget that we are going to 50. So this is 50 here. So I've already worked. Now let's measure from this end now. Is it 50 already? So we are there already, 50. So that's 50. So 50 now. 50. You reset your stopwatch, stop it and reset it. So 20 oscillation after the count of 2. 20 oscillation after the count of 2. Yeah. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I was 28 here. 28 point what? 0.47 seconds. So that's that. So after that with our measurement and recording now, let's go to our table to evaluate the rest. We have M in centimeter, we have T in seconds, we have the period, which is T all over 20, which is also in seconds, and we have root of L, which is also in centimeter. So now we are asked to evaluate evaluate T and with L. Now from here now, 38.2 divided by 20. So we have 1.92, 1.91. Here, 36 divided by 36 divided by 22. We have divided by 20, 36 divided by 20. We have 1.811. So to 3 decimal place here, let's put this one to 3 decimal place. So 33.112 divided by 20. 33.112. We have 1.656. We have 31.20 divided by 20. We have 1.546. Now, lastly, we have 28.47 divided by 20. We have 1.423. So that's that about the period. Now for the L. So with L now we have square root of 90 to 3 decimal place. We have 9.486. So 9.486 square root of 80 now. 8 points square root of 80, 8.944. So square root of 70. Square root of 70 here we have 8.366. Square root of 60. 7.745. Then square root of 50. 7.071. So that's that about the table now. So we are done with the table of reading now. So what is the next thing to do now? Tablet your reading, plot a graph of T, the period against with L. Plot the graph of of T against root L. That plot the graph of T against root L. But before that, I would like to bring out my value here because I'm going to add the banner here very soon. So the first thing I'm going to do now is to try to clean this off now. To clean this off to this extent. Now write my table of values to this place. So that's what I'm going to do now. So we have to plot the graph of So table of values. Table of values. Now, table of values to be plotted. Now, table of values to be Table of values to be plotted. Okay. To be plotted. Now, they have we have the T against with L. Both this one is in centimeter and this one is in seconds. Period is in seconds. So we have 1, 2, 3, then 1, 2, 3, 4, then 5. Now we have for for root L, we have, and for what? Let's now, from here now, we can see that every of my points here falls between 1.4 to 1.56, 1.6, 1.8. So now, at least to the nearest what? 1 decimal what? Place now. I should be able to locate this to the nearest what? 1 decimal what? Place. If not what? 2 decimal place. So now let's do this to the nearest what? 1 decimal place. Can we locate 2 decimal place? 2 decimal place will be kind of difficult. So 1 decimal place, about 1 decimal place to what? This one will be what? 1.9 for the 1.9. The next one will be what? 1.8, 1.65, 1. What? Sorry, to 1 decimal place, we have 1.8, 1.7. We approximate this one to 1.7. So it's 1.9, so it's up to 5. That's why I think 1.9, 1.8, 1.7, 1.6. Then 1.4, 1.9, 1.8, 1.7, 1.6, 1.4. So the root N here is what? Now to 1 decimal place as well here, we have what? 9.5, 8.9, to make all this 8.4, we have 7.7, then we have 7.1. So that is that. This table to be plotted, table of values to be plotted now. So now that's that. So I can now hand my what? My graph. So welcome back. We have posted our graph here, and I will summarize our table of values to be plotted. Now we have our TS, we are putting to 1 decimal place, and our root N also to 1 decimal place. Plot a graph with T on vertical axis and with L on horizontal axis. Determine the slope of the graph. Now we have to plot the graph of T against what? Against root L. So we write the vector of the graph. Graph of T, which is the period in seconds, against root L in centimeter. Root L in what? In centimeter. So root L in what? In centimeter. Now here we have what? We have our what? Our T bracket S. The highest value here is what? Is 1.9, and the what? The lowest value here is 1.4. So if I want to choose a scale now, I have to get to what? 1.9. I will have to use what? 2 centimeter represents what? 0.2, because I have almost like 2 centimeter box here. Almost like from here to here, I have 10 2 centimeter boxes. From here to here is 2 centimeter. From here to here is 2 centimeter. So if I count this box now, I have almost 10 boxes along this vertical road. Along this vertical axis. So 0.2 times 10 will give you 2.0. So I'm going to what? I'm going to 1.9. So that I'm going to use 2 centimeter represent 0.2 seconds on what? T axis. So we have what? 2 centimeter represent 0.2 seconds on T axis. That is the period axis. So that's that about that. So now let me root that one out so as to see what I'm trying to say here. So here, now before that, let me also conclude on the scale where the scale that I'm going to use in what? In the horizontal axis, which is root L. Now, what scale will I use for what? My horizontal axis, which is what? Root L. Now look at this place now. We have what? 9.5. This is the highest value, 9.5. Now I have 2 centimeter boxes here, and number of 2 centimeter boxes that I have here is what? It's also 10. If I count now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So meaning that if I use what? 2 centimeters represents 1 unit. I'll be able to get to exactly 10. So meaning that what I will start drawing my what? My horizontal line from the extreme end here, so that to be able to go to get to what 10. So in order to draw my vertical what line now, I need to what? Write the scale of what? Of the root N axis as well. So 2 centimeters represents 1.0 centimeter on 1.0 centimeter on root L axis, So that's that. So now I'm drawing my vertical line now, which represents the what? The period axis, which is T axis. So now, let me see whether this one will be enough. We have what? We have 0 here, 0.2. Is it up to what? Is it up to 10? Then right, let's start from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should go for what? 10. You should be able to what? Reach 10. So now, let me draw my vertical here. From here now. By horizontal rather. So I'm drawing the horizontal line as well. So now, this is the T axis. The T axis, which is what? Which is in seconds. Then we have the root what? L axis, which is in centimeter. So now, we said 2 centimeters represents what? 0.2. So from here to here, it's going to be what? 0.2, 0.4. This is 0.4, 0.4. 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8. Now we have what? 2.0 here. So let me just adjust this. This 2.0 here. 2.0. So we have what? 0.2, 0.4, 0.6, 0.8, 1.2. Okay, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2. Sorry, this was supposed to be 1.2, 1.4. 1.4. From here to here is what? 1.6. 1.6, this one should be 1.8. And the other one should be what? This one will be what? 2.0. So now we have what? 0.2, 0.6, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, and 2.0. That is 0.2. That's 2 centimeters represents 0.2. So that's that about that. Now on the horizontal axis on the horizontal axis we have 2 centimeters represents 1.0 centimeter on root L axis. So it means that for every 2 centimeters I'm going to have what? 1.0 centimeter. So 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0, 8.0, 9.0, then what? 10.0. So that's that about what? About the what? The root L axis. Now let's plot what? The values on the graph. Now we have what? 1.9. Now to know how to plot the value on the what graph. This 1.9 against 9.5. Now, not even where that what the 10 boxes here is equivalent to what? 0.2. So 0.2 divided by what? 10 is 0.2. For the vertical axis here is 0.2 divided by 10. We have what? 0.02. So meaning that what? Each box on the vertical axis is what? 0.02. So if I'm to locate what? 1.9 now. If I'm to locate 1.9, I have 1.8 here. So 1.9 will be what? 1.9. If I have 1.8 here, this one will be 1.82. Because each box is 0.02. 1.82, 1.84, 1.86, 1.88, this is 1.9. So 1.9 is along this space. Yeah? 1.9 here. Against what? 9.5. 9.5. Here we have what? 10 box subtracting what? 1.0. So 10 box here. 1.0 here divided by 10 box. So it means that each box, smaller box will be 0.1. So if this is 9, this will be 9.1, 9.2, 9.3, 9.4, 9.5. So trace this 9.5 against 1.9. This is 1.9 here against what? 9.5. So 1.9 against 9.5 would be what at this place? We have what? We have 1.9 against what? 9.5. So that's that about that. So now from here I have noted what? First point. The second point. How do we go about the second point? So 1.8 against 8.9. 1.8 against 8.9. Now 1.8 against 8.9, we have 1.8 here. 8.9 will be around this place because this is 8.5, 8.6, 8.7, 8.8, 8.9. So 1.8 against 8.9. We trace. Now we have our point here. So 1.8 here. Then 8.9 here. So here's another point here. So that is 8.9 against 1.8. Now another one is what? 1.7. 1.7. If you count this one now, 1.6 to 1.64, 1.66, 1.68, 1.7. So 1.7 against 8.4. 1.7 against 8.4. 1.7 against 8.4. So we have 1.7 against 8.4. So these are 1.7 here. Please note that 8.4, 6, 8.5, this 8.4. We trace it down now. So 8.4 against what? 8.4. This 8.4. So 8.4 against 1 point what? 1.7. This is 1.7 against 8.4. So that's that about that. Now 1.6 against 7.7. 1.6 against 7.7. So we have 1.6 here against 7.7. We have what? 1.6 against 7.7. We have what? 7.5, 7.6, 7.7, 7.7. 7.7 against what? 1.6. 7.7 against what? 1.6. So here we have value here. So that's another value for us. Now 1.4 against 7.1. 1.4 against 7.1. 1.4 against 7.1. We have 1.4 here. Then 7.1. 7.1 will be here. 7.1 against 1.4. So we have it here. We have it here. So that's that. Now we have to join these points together now. Let's join it with our ruler. Now I will have to No, we are not asked to calculate intercept. So choose. So you can just draw it. You can draw it in any way you like, because if it has horizontal intercept, you must draw it in such a way that it will cut the horizontal axis. But now we have no intercept, whether it's horizontal or vertical, no intercept. So draw it in order to have a maximum point here. So now I look at this one very well. Which one? Okay, if I choose these 3 points, I think it passed through these 3 points. So let me bring my ruler down. So to complete it now. So that's my straight line. So don't forget that there is one point here. So there's another point here. So I have point on this line as well. That to be visible. So that's about that. So we can see it takes really 3 points. So it means that the graph is very okay. So with that now we can now draw our Let's find our slope. And how do we go about our slope? Just pick convenient points, the convenient point for you. So now I'm picking this one now. I'm picking this point here. So against this one now, I'm looking for another point to pick. Okay, let's go by this. Looking for a perfect point. Okay, I think this one. So you rule from here now. So you join it together with this. So that's about that. So here we'll be able to draw a slope. Now we can draw a right angle inside. So that's that. Now let's choose the suitable point. Now let's calculate our slope by placing this one to the vertical axis. Now change this one down to the dashed line. What it's fair. So that's about that. So now to the other one, this one we can target T2. This is T2. This is T2 here. So here we have trace this one to the other end here as well. So this is T1. So this one is root L1. So this one is what? This side is root L2. So we have root L2, L2. So now calculating your slope now. How do you go about that? Calculating your what? Slope now. We have your slope is what? Change in S equal to what? Change in S is equal to change in T all over change in root what? Root L. So that's your slope. That's the formula for your slope. So meaning that what? T2 minus T1 over what? Root L2 minus root L1. So what does that mean? What's our root L2? Root L2 is 9, our T2 first. Now, our T2 is 1.8, 1.82. 1.8, 1.82. So we have what? 1.82 minus what? Minus T1. We have 0.2 here, 0.22, 0.24, 0.26. So this place is 0.26, 0.2, 0.24, 0.2, okay, 0.2, 0.22, 0.4, 0. Okay, let's read it again. This is what? 0.2, 0.22, 0.24, 0.26. So this is 0.26. So that is how to read what? That in what? In seconds. Seconds. That's the unit. Then the root what? The root L2 is 9.0 centimeter minus what? 2.0 centimeter. 9.0 plus root L2 here is 9.0. This one is what? 2.0. So 9.0 minus what? 2.0 in centimeter. So pressing your calculator now, we have what? We have 1.82 minus 0.26. So we have 5.6. 1.56 seconds all over 7 what? 9.0 is what? 9.0 minus 2.0 is going to be 7.0 centimeter. So divide that one. So we have, what do we have now? So 1.56 divided by 7.0. We have 0.222. 0.2228 what? 8 seconds per centimeter. So approximately what? 0. What? 3 decimal place. 2 to 3 square 0.223 seconds per centimeter. So that's that for the what? For the slope. So that's that for the what? For the slope. We have gotten what? 0.223 centimeter what? Square centimeter. So having gotten what? The slope is 0.223 seconds per centimeter. Now what is the next thing that we have to calculate? We have to calculate what? Evaluate G equal to 4 pi square all over x what square. 4 pi square all over what? X what square. Now how do you go about this? Evaluate G is equal to what? And to evaluate G. Evaluate G is equal to 4 pi square. 4 pi square all over what? X what? Square. Now G is equal to what? 4 pi square all over what? X square. Now what is pi? Let's calculate the G. So what is pi? Pi is 3.142. Now x is what? From your slope now, x is 0.2228 seconds per centimeter. So don't use approximated value, just use the one that has not yet been approximated. Now substituting your value now, your g now will now be equal to 4 times 3.142 all square all over what? 0.228. Now we have carry out the unit along seconds per centimeter all what? Square. It's very, very essential. So now multiply the numerator first. 4 times open bracket 3.142 bracket to square. We have what? 39 point what? G is equal to 39.4886 all over. Now when you square this one, 0.2228 square divided by 0.0496 4 decimal place. Now when you square this unit as well, it will be second square per square centimeter per square centimeter. So we now have what now? 39.4886 divided by 0.0496. So this is what? So we have 30. So 4 times what? So we have what? 39.4886 divided by what? 0.0496. So we have 7 what? G is equal to what? 796.4 seconds. Now when you're taking second, when second goes up now, it will be what? It will now be what? This one goes up, it will now be centimeter square. Then per what? Centimeter square per second square, centimeter square per seconds. So centimeter square per second square. Now that's that. So that's that about your G. You calculate your G from what? From your slope, as we have been what? Told to do so. So now that's that about that. So we calculated our slope, which is 0. So we have calculated our slope, and thereafter we have calculated our G. Now let's go to do what? To the meaning what? Question here. We have what? 11 now. Remember what? X1. That's number 11. State 2 precautions taken to ensure accurate what? Result. Number 1 is that I avoid what? Error due to parallax when taking my reading of what? Meter rule. I avoid error due to what? Parallax when taking reading on my meter what? Rule. Number 2 is that what? I avoid what? Ear resistance. That is, there is no what? Interference of what? Ear resistance. I try as much as possible to switch off my fan to avoid what? Ear resistance. So number 1 is that you avoid error due to parallax when taking your reading on meter rule. You also avoid what? You also avoid the ear resistance in averting your oscillation of the pendulum, and also you avoid the rotational motion. So you ensure that the pendulum does not undergo rotation motion, and as well as you avoid zero error or when taking your reading on the stopwatch. So almost like 4 precautions that you can write on this aspect. Avoid error due to parallax, and ensure that that there is no ear resistance. Now I also avoid the rotational of what the rotational motion of what of pendulum, I show that what the pendulum what oscillates to and what through, and that's that. Now in the next, this one's supposed to be centimeters per half. Please note that 6 centimeters is supposed to raise to power half. So per centimeter is to power half. So the unit here, this one's supposed to be per centimeter is to power what? Please need to take note about that. It's very, very so because this root is carrying what, this root here is carrying what, this here is carrying root, so it's what minus 1 all over what 2. This one also minus 1 over 2. That is what showing that what the root here is what is carrying what, this area is carrying what root. So this one also will be what root what. That is 1 raised to power centimeter minus centimeter raised to power what half. Now I need to correct everything. Centimeter raised to power what half. Also on my table, please ensure that I correct that. So centimeter over what? Centimeter raised to power what half. Centimeter raised to power what half. So that is very, very important. Centimeter raised to power what half. So now your what? Your unit here will now cancel. This one will cancel this one. It will only become what? Centimeter raised to power 1. Now please, this is what? Centimeter raised to power what? 1 half. Now 1 over 2 times what? 2 will give what? Centimeter raised to power minus 1. Then this one will now give what? Centimeter raised to power what? Minus 1 now. So when this centimeter raised to power minus 1 goes up, it becomes what? Centimeter per second square. So that's that about that. So your unit of what? Acceleration due to gravity must be what? Must be in what? Centimeter per second square. So not in what? Not in other way what round. So that's that. So having gotten our G now, the last question says Pendulum says determine from your graph the period of what? Of the pendulum for L. Determine from your graph the period of the pendulum for L equal to what? 75 centimeters. Determine from your graph. So from the graph, we have to determine the period T, which is unknown, at what? At L equal to what? 75 centimeters. Now when you look at the period here, when you look at what? The graph given to us, or the graph that we've drawn out, we can see that the graph is T against what? Root L. We only have root L, not L. So we have to take L to root L by what? Finding what? Root L, which is root 75. Root 75, now when you press your calculator, it will be root 75. Our calculator is 8.660. Now 8.660 centimeter raised to power what? Half. So 8.660 centimeters per half. So root L now is equal to this L is now what? Approximately what? 8.7 centimeters per what? Half. So now you trace this on the graph. You trace this one on the graph. So let's use another what? Another column marker. This is having already. So now 8.7 is what? That's what? 8.7 is this 8.5 I mean. 8.6, 8.7. This 8.7. So if that's 8.7, you trace this 8.7 to meet what? 8.7, you trace it to meet this line. So meaning that what? 8.7 is here as well. So if this is 8.7, so when you trace it to join this one, 8.7. So this is 8 point what? This is 8.7. So we have 8.7 here. So from here now, this 8.7 to the other side here, you trace it as well to the other side here. It's very, very important that you trace it out. So 8.7. So the corresponding what? Period for root 8 for 8.7 is what? Let's check it now. So that's why we're tracing it out. So here now the corresponding value for what? For 8.7, the corresponding value here is 1 point what? Now this 1.7, 1.7 to 1 point what? 74, 1.76. So T is 1 point what? 1.7 what? 1.76. So for here now we have what? Our what? For root L what? T here now. For root L T. For root what? For root L T. For root L, which is 8 what? 8.7 per centimeter. We have what? We have T to be equal to what? T is equal to 1.76 what? Seconds, which is the same thing as what? So therefore, for L equal to 75, the time or the period is equal to 1.76 seconds. As you can see here, 1.76 what? Seconds. This is the value 1.76 seconds. So that's that about what? About the graph for what? For the what? Simple pendulum what? Experiment. So I've come to the end of today's class. Please, if this video has helped you, please do press the subscribe button and notification bell. That's all our videos online. Thanks for watching once again. Keep on watching the videos and academic tutorial, and God bless you.